Good morning everyone. My name is Ruchita Shantra and I will be talking about thin layer chromatography technique. So let's start with what is chromatography. Chromatography is a physical method of separation of mixture in which components to be separated are distributed in two different phases. One is the stationary phase and second is the mobile phase. Let's see what are the commonly used different chromatographic techniques. Some are adsorption chromatography, paper chromatography, affinity chromatography, thin layer chromatography, gas chromatography, etc. In this video, we will be talking about thin layer chromatography in details, like what are its principles, what is the methodology, what are the different techniques used to develop the chromatogram, and various reagents to visualize the separated components. Let's start with what is TLC. TLC is a form of liquid chromatography which consists of a mobile phase and a stationary phase. It is one of the fastest, easiest and least expensive chromatographic technique which is used for qualitative and quantitative analysis of compounds. It is also commonly used to test the purity of compounds. So if we talk about the definition of TLC, it can be defined as a method of separation or identification of mixture of components into individual components. TLC is also known for various synonyms like spread chromatography, drop chromatography, surface chromatography and strip chromatography. Let's talk about the principle involved in the separation of components in TLC. The components separate based on the principle of adsorption. Compounds to be separated are spotted on the stationary phase and the mobile phase is allowed to flow through it. The mobile phase flows by the capillary actions. So the components move according to their affinity towards the adsorbent. So the component with more affinity towards the stationary phase will elute out slower and components with more affinity for the mobile phase will elute out faster. The basic theory which is involved to determine the migration of the components in TLC is by the use of RF value, which is retardation factor. It is calculated by distance moved by solute divided by distance moved by the solvent phase. As you can see in this picture, the topmost blue mark is the distance traveled by the mobile phase and the followed components are the different separated components from the mixtures. Let's talk about various components of TLC. First is the stationary phase. Various components are used like silica gel G, cellulose powders, but the most commonly used is the silica gel for stationary phase. Glass plates are used to prepare the stationary phase. Various dimensions are available like 20 by 20 is for full plate, 20 by 5 is for quarter plate and 20 by 10 is for half plate. Next is the mobile phase. Appropriate solvent is used as a mobile phase depending upon the compounds which are to be separated. Next is the development tank. There are certain criteria which need to be maintained, like it must be saturated by the mobile phase to prevent the edging effect before starting the TLC process. And last are the various detecting and visualizing agents. There are specific and non-specific agents to detect the separated components. We will be covering this in later part of the video. There are certain selection criteria of the adsorbents, like solubility of compounds, that is whether they are hydrophilic or lipophilic, what is the nature of the substance to be separated, that is whether they are acidic or basic in nature, what is the particle size of adsorbent, what is the reactivity of compounds with binders, is there any chemical reactivity happening between the compound and the mixtures of the solvent to be separated. So these are the criteria which need to be kept in mind before selecting the adsorbent. After selection of adsorbent, we go for the preparation of the TLC plate. There are various methods involved like pouring, dipping, spraying and spreading. Spreading is the most acceptable method for preparation of TLC. After preparation of TLC plate, we go for activation of TLC plate. So it involves the removal of water by heating at a very high temperature. These activated plates are then stored thermostatically in a control oven and used whenever it is required. Now there is a video which will show us how to perform a TLC. Let's start with the video.
A pencil line is drawn, about 1.5 centimeters from the bottom edge. Also, the plate can be labeled using a pencil to show the original position of the drop. Thin layer chromatography can be used to identify compounds present in a given sample mixture. A small drop of the mixture is placed on the baseline of the thin layer plate. And similar small spots of known compounds are placed alongside it.
So this is how we spot the samples on the TLC plate.
When the spots are dry, the TLC plate is then placed in the chamber so that the spots do not touch the surface of the eluent in the chamber, and the lid is closed. The solvent moves up the plate by capillary action, meets the sample mixture and carries it up the plate. The separation is based on differential partitioning of the sample components between the mobile phase and the stationary phase. The component which has less affinity to the stationary phase, consequently, less interaction, travels further up the TLC plate. And the component which has more affinity to the stationary phase, consequently, more interaction, travels slower on the plate. This separation can be carried out according to the nature of the mobile phase, which is non-polar, and to the TLC plate type, which is generally a polar stationary phase. In this case, this method separates analytes based on their affinity for a polar stationary surface, such as silica gel. The more polar the analytes are, the more retained they will be on the stationary phase. The more hydrophobic they are, the more they will prefer the mobile phase, and as a consequence, they will move higher up the plate. The solvent is allowed to rise until it almost reaches the top of the plate. That will give the maximum separation of the components. The plate should be removed from the chamber before the solvent front reaches the top of the stationary phase. Then this front is marked. The plate can be dried in ambient air, or under the warm air of a dryer. The plate is visualized under the UV lamp, or by using certain chemical reagents, if the substances of interest are colorless. Some plates are
After this, we go for the development techniques. TLC can be developed into various dimensions. This one you can see is the one dimensional, where the development takes place only in one dimensional. Next is two-dimensional development technique. Here, we first develop it into one dimension and then again use it as a base for development in the second direction. So this is why it is called as two-dimensional development techniques. Beyond this, there are other development techniques like vertical development and horizontal development. After the development of the chromatogram, we go for the detection of spots. It can be by using physical methods or chemical methods. Certain non-specific methods are like UV chamber, sulfuric acid and iodine chambers. And certain specific methods where we use specific reagents like ninhydrin is for amino acid, drag and drop reagent is for alkaloids, and ferric chloride is for phenolic compounds. So let's see how to detect the components by using UV chamber.
Plates are pre-coated with a phosphor, allowing many compounds to be visualized by using ultraviolet light. Or a derivatization of the sample with fluorescent reagent can be carried out before running the TLC plate. As soon as the UV source is switched off, the spots will disappear again. Therefore, the positions of the spots should be marked by drawing a pencil circle around them, and the retention factor of each component is determined.
Next is the detection by the chemical reagents.
For chemical visualization of stains, various visualizing agents react with the spots to produce visible results, such as iodine, ninhydrin, potassium permanganate, and vanillin. The plate can be immersed in these chemicals, or sprayed. Once visible, the RF value, or retention factor, of each spot can be determined by dividing the distance the compound traveled by the distance the solvent front traveled, using the initial spotting site.
So after spotting, we go for quantitative analysis. This is done by calculating the RF value. It is calculated by distance traveled by solute divided by distance traveled by the solvent front, that is the mobile phase. The RF value should be in between the 0 and 1. RF value more than 1 is not acceptable. So let's talk about various applications of thin layer chromatography technique. First is the separation of amino acids. It is commonly used to identify various amino acid components. It is also used for the separation of vitamins. Third is the separation of alkaloids, glycosides and antibiotics. And lastly, for the separation of inorganic ions. That's all. Thank you.